Hello and welcome everyone to this live session, and today we are going to cover motion in a straight line, the entire chapter. Yes. So all of you, any of you like having backlogs, welcome to attend this session. We'll be covering a lot of questions, all the concepts, yes, but with a good speed, okay, because we have to cover everything in just 3 hours. So let us begin this discussion. Okay, motion in a straight line. So first of all, let us understand frame of reference thing. Frame of reference means you are observing the motion. Okay, let us take you are observing the motion of a bike standing on the ground. Okay, or you are observing the motion of a bike sitting in a train, isn't it? The bike is the same, but observation will change. Why? Because the frame of reference has changed. Okay, so frame of reference means like with respect to whom you are observing that motion. Okay, your frame of reference can be the ground, it can be a train, it can be a bike, it can be, let us say you are standing in the lift, it can be the lift or like that. Okay, so when we say a particle or an object is in motion or that is at rest, it depends. Okay, like if I ask you whether I am in rest or I am in motion, you will say, sir, you are at rest. But I will say, I am in motion, I am not in rest. I am not at rest. Why? Earth is rotating and it's revolving also around the sun. So how can I be at rest? If you observe me outside Earth, let us take you are in space and then you are observing, then you will say, I'm in motion. But you are standing near me and then you observe, then you will say, I'm at rest, isn't it? So it depends how we are observing, means what is the frame of reference. Okay, so you cannot like just say this particle is in rest or this particle is in motion. You have to define your frame of reference. With respect to ground, the particle is at rest. With respect to let us take earth, the particle is at rest, or with respect to, let us take the train, the particle is at rest. Okay, it depends. Hello. Sir, is AIR 100 from now possible if I do proper study from now? JEE 2028. Oh, UK IIT. Yes, lot of time you have. If you become serious now, still you can improve. Okay. Now position. How we define position of a particle? So to define the position of a particle in 1D, let us take my particle is moving only along one dimension. One dimension means you can take along x-axis, you can take along y-axis. Okay, so let us take my particle is moving along x-axis. Okay, so I will say this is my x-axis. This is x is equals to 0, 1, 2, 3, 4. This is x is equals to -1, -2. Wherever the particle is, let us take the particle is here. So I'll say my position is x is equals to 3. Okay, like that. So how I'm defining my position? I'm defining my position with my x coordinate because my particle is only moving along 1D. Okay, so here I'll say the position is, what is the position? X is equals to 3. Like this. If the particle is somewhere here, maybe x is equals to -1, then I'll say the position is x is equals to -1. Okay. Yeah. Now let us talk about the position in 2D and 3D. Yeah, my father is okay now. Sir, please send notes. We didn't get any. The last class notes I shared with the team. I don't know why they didn't share it. I'll again connect with them. Okay. Yeah, the notes will be shared, so don't worry. I'll ask them again to share the last class notes and this class notes also. Now 2D or 3D, let us take your particle is at some x is equals to some maybe 5, y is equals to maybe 2, z is equals something. So there we define the position vector. Okay, there we define our position vector. So when I write my position here, okay, that I define with a vector, and that will be the x coordinate I cap, y coordinate j cap, z coordinate k cap. This is how we denote our position, because now you cannot say just, x is this or y is this or z. No, you need all the three. You need all the three. Here I just need one x because my particle is moving along x-axis only. Certainly I can write my position as 3 I cap also, but there I cap j cap is not needed because I know only x coordinate is there. So why to specifically mention that? But here I cap j cap k cap is needed because there can be x coordinate, y coordinate and z coordinate. Okay, so accordingly we denote it like this. You can take an example. Let us take, this is my x-axis, this is my y-axis, this is my z-axis. The particle is somewhat here at 1 comma 1 comma 3 like this. Okay, how we define the position? So I will say my position vector is equals to 1 I cap, 1 j cap, 3 k cap, like that. And how we denote that vector? Okay, from origin. So that vector is this. So I'll say this is my position vector. This is my position vector. Okay, so this is how we define the position. Next is the distance and the displacement. Basic difference you all know till now. Okay, distance is the total path length the particle is covering, and the displacement is just the shortest path between between the 2 points, initial and the final position. This is how we define, like that is the rough idea that you get in your 9th standard. Okay, so let me first talk about the displacement. Okay, when I say it's just the shortest distance between the two, it's incomplete information, means I'm not telling about the direction there. Displacement is a vector quantity. Here the magnitude is also there, the direction is also there. Okay, when I'm saying just the shortest distance between the 2 points, it is just the magnitude, no direction information is there. Okay, therefore the complete information is in the definition when we say the displacement is equals to change in the position. Okay, it is equal to change in position of the particle. Okay, let us see how it works in 1D and general 2D, 3D. So let us take for 1D. For 1D, I'm denoting, this is my axis 1, here 2, 3, 4, -1, -2, -3. Let us take the particle was initially at x is equals to 2 and then it went to x is equals to -1. I will say this is my initial position, this is my final position. Okay, so when I'll say displacement here, I'll say displacement is equal to change in position, the final position minus initial position. What is the final position? -1. What is the initial position? 2. So this is -3. The displacement is -3. Where is the magnitude? 3 is the magnitude. Yes, 1 unit, 2 unit, 3 unit. Total displacement magnitude is 3. What is the significance of minus sign here? Direction. It is towards the left, therefore a minus sign is there because it is towards the negative x-axis. Okay, similarly if I have to denote the position, if I have to denote the displacement in 2D or 3D, okay, let us take the particle moves from initial position x1, y1, z1 to my final position x2, y2, z2. Okay, when we denote the displacement in this case, so we will write that the displacement is equal to, you may denote displacement with d or sometimes we use s. So that is final position minus the initial position. This is how we write it. Okay, what is the final position vector? x2 I cap, y2 j cap, z2 k cap minus initial position vector x1 I cap, y1 j cap, z1 k cap, huh? Like this, and then you subtract x2 I cap from I cap, j cap from j cap, k cap from k cap, like that. Okay, so it will become x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. So this is my displacement vector. Huh? How to find the magnitude of this? Take root x square plus y square plus z square. That way it will become whole root x2 minus x1 square, y2 minus y1 square, z2 minus z1 square. Okay. Let us solve this question here. A cyclist starts from point P. Okay, the cyclist starts from this point. Okay, it starts from point P of a circular ground of radius 2 km, travels along its circumference to point S. The displacement of the cyclist is. Now it comes like this here. Now what is the displacement? Now here direction is not asked, just the magnitude. If you have to, what y cap, cap denotes the direction. Yeah, somebody is asking y cap here. When we are writing I cap, j cap, k cap, it means this much along x axis, this much along y axis, this much along z axis. Okay, I cap denotes the displacement along x axis, j cap for the y axis, k cap for the z axis. Okay, these are unit vectors along x axis, y axis, and z axis. Okay. So here I am able to get the idea that okay, the displacement along x-axis is this much, along y-axis this much, along z-axis is this much, that way. And also next was the distance. Now let us talk about distance, then we will move to the question. What is distance? Distance is the total path length covered by the particle. Total path length. Let us take, this is my x-axis. Okay, I am first talking about 1D. 0, 1, 2, 3, minus 1, minus 2, minus 3. Let us take the particle was here and then it goes like this and then came back till here. Now in this case, if I ask you the distance, total path length, this plus this, okay. So here when I say distance, that will be equal to, how much is this? This is 2, and how much is this? This is from 3 to minus 2, that is 5. Okay, so 5 plus 2, 7. Total distance covered is 7 units in this case. Okay, you can attend if you can get things here. Okay. Now if let us take the motion is 2D or 3D, let us take an example of that. Okay, let us take for 2D. This is my y-axis, this is my x-axis. A particle was here initially and the particle goes somewhat like this and reaches this point. Okay, this is my initial position, this is my final position. Now in this case, if you have to write the distance, you have to take the total path length. Total path length means this total length. How to get that total length? It depends on the equation of the curve. Okay, it will depend on the, you cannot directly write that path length, isn't it? You need to know the equation of this curve and then you can calculate the total path length here. So this total is my distance in this case. Finding displacement is a easy task. Finding distance is actually a difficult task. We will do some questions and you will see that finding distance actually a bit difficult. Yes, a bit difficult. Finding displacement is very easy. Okay, here we had to find, here my particle was moving from position P to S like this. And we need to find, not like this, sorry, like this. P to S like this it is moving. Okay, and here we have to find how much is the displacement. Now When we came to the options, direction is not needed. It is only asking about the magnitude of the displacement. So magnitude of the displacement means the shortest distance between the two. That is this. Okay. This is radius. This is radius. How much will be this? R root 2 in this right angle triangle. You can use Pythagoras theorem. That will be R root 2. So what is the radius? 2 kilometers. So the answer will be 2 root 2 kilometer. And what is 2 root 2? That is root of 8 kilometers. Clear? Easy question. Now, let us talk about the average speed. How average speed is defined? That is distance divided by the time interval. So, our average speed is equal to the distance divided by the time interval. Distance covered by the particle divided by the time it takes to cover that distance, that becomes our average speed. If you talk about average velocity, instead of distance, I'll take displacement. Okay, for average velocity, I'll write this as the displacement divided by the time interval. Okay, let me write separately for 1D or general motion. Okay, so for 1D, if I write my average speed, okay, average velocity, V average, so that will be my x2 minus x1. Displacement is equal to change in position, x2 minus x1 divided by t2 minus t1. This is the time it takes. Okay, and if I write for 2D or 3D motion, then I'll say that my average velocity will be equal to displacement is change in the position divided by the time interval. So the difference in the position vectors R2 final position minus initial position divided by final time minus initial time. Clear? Let us do some questions on this now. Yeah, total displacement divided by total time taken. Very good, Yuvraj Gupta. So a particle that covers half the distance with v1 speed and other half with v2 speed, find the average speed. Okay, let us take the particle is going from some point this to this. Okay, so the particle is going like this. Now what it is doing is, it is covering half the distance with v1, other half with v2. Okay, I am taking total distance to be d, so this half d by 2, this half d by 2. Okay, so half the distance with v1, here the speed is v1, here the speed is v2. Now you have to tell what is the average speed. So I will say that average speed will be equal to the total distance. What is the total distance? D by 2 plus D by 2, D divided by the time it takes. Okay, let us take here, from here to here it is taking time t1. From here to here, let us take it is taking time t1, and in the next half from here to here it is taking time t2. Let us take it like this. So I'll say total time will be equal to t1 plus t2. t1 plus t2, isn't it? t1 plus t2. Now d divided by, if I ask you what will be t1, so you will say, sir, the distance is d by 2, speed was v1, so t1 will be d by 2 v1. Here, what is t2? You will say, sir, distance is d by 2, okay, divided by the speed was v2. So I got t1 and t2. Put the t1 and t2 here. Put the t1 and t2. What is t1? D by 2v1 plus t2 is d by 2v2. D and d are getting cancelled. So what we will get from here? 2 v1 v2 divided by v1 plus v2. 2 v1 v2 divided by v1 plus v2. Getting it? Yeah, very good. Jaya, yeah, good, you got it. Sir, can we apply caps on this? On which thing you are talking about? Huh? Where you want to apply caps? Here? No, here just we are finding the average speed, okay? Just the magnitude, okay? So, need not write cap here, huh? When like here we are applying caps, here we are applying caps, okay, x2 minus x1. Here we know separately about x-axis, y-axis, z-axis displacement. This is displacement along x-axis, therefore this much I cap. I cap is to denote it is along x-axis. J cap is to denote it is along y-axis. Similarly, k cap is to denote it is along z-axis, like that. Okay. Next question. A particle that travels half the time with V1, another half with V2. Now here distance is not half, here time is half. Previously distance was half. Okay, so let us see. Let us take the particle is going from this point A to point B. Okay, it goes. Now for let us take total time it takes is T. Total time it takes T. So for half of the time, not half of the distance, for half of the time, let us take this is half of the time, okay, from here to here it takes T by 2, okay, and for the next half from here to here it takes time T by 2. Clear? Half of the time, not the distance. Then let us take here it covers a distance d1, here it covers a distance d2. Clear? Now when we write average velocity or average speed, I will say the total distance here, that is d1 plus d2 divided by the total time here, that is t. What is d1? Speed was v1 here. Here the speed was v2. So what is d1? d1 will be v1 into t by 2. v1 into t by 2. Similarly, what is my d2? Here speed is v2, time is t by 2. So v2 into t by 2. Clear? Put them here. So v1 into t by 2 plus v2 into t by 2 divided by t. So this t is getting cancelled. I got this as v1 plus v2 by 2. This is my average speed. Now you see there is a difference. Here we were getting 2 v1 v2 divided by v1 plus v2. Here we are getting v1 plus v2 by 2. Huh? Okay. So there is a difference between half the distance and half the time. Most of the students are confused in this. Okay. Next question. Another simple question. This is a Erudito question actually. Okay. You I think all know what Erudito is. Erudito is a JEE advanced level book of physics. Let us solve this question from Erudito. Now, a man travels half the distance with velocity v naught. Okay. Again, the same thing. Like let us take it is going from this point A to point B, somewhat like this. Now, total distance you may take d. Half the distance it is traveling with velocity v naught. Okay, this is half. So I'm taking this distance as d by 2. The other half is also d by 2. Now this first half d by 2, it is traveling with velocity v naught. So from here to here when it is going with v naught. Then the remaining part of the distance was covered with velocity v1 for the half of the time, v2 for the next half of the time. Now this second interval is divided into two parts. I am taking from here to here, it took time. Let us take, you can say t naught, okay, t naught. In the next half, you can take this, not t1, let me take this time as, what should I take, t1? No, then v1, v2 thing is there. v1, v2 is there. Okay, let us take it takes time t naught here. In the next half, let us take from here to here, it takes time t2. Now, this t2 interval is divided into two halves. The first where the time is half of the total and the second is also half of the total. So first half it is moving with velocity v1, means from here to here it is moving with velocity v1, from here to here it is moving with velocity v2. The first half time is my t2 by 2 and this is also T2 by 2, like that. Now here my motion is divided, like total distance was d, cut that into two parts, first half with speed v naught, now the rest half is divided again into two, now not with distance but with time. Whatever time it takes for the second half of the time with v1, next half of the time with v2. Now you have to tell, find the average speed of the man in this particular case. Okay. Value putting questions will be there, don't worry about that. Okay, we are understanding some concepts and then value questions will come, don't worry. Okay, so when I say V average, I'll say that is equal to my total distance. What is the total distance, by the way? D by 2 plus D by 2. I can just write directly D divided by the total time. What is the time here? T naught plus what is the time in this particular interval total? That is my T2. Now here I don't know D, I don't know T naught, I don't know T2, I have to substitute them, then I can write it properly. Okay, D divided by, what is T naught? The time it takes to cover half of the distance with velocity V naught. Time will be distance divided by speed. How much is the distance? D by 2. Okay, how much is the distance? D by 2. So D by 2, what is the speed? V naught. Put it here, D by 2 V naught plus my T2 time. Okay, now what is the next half distance? Next total half distance is my D by 2. This D by 2 distance will be this plus this. How much is this distance? Velocity is V1, time is T2 by 2. So V1 plus V1 into T2 by 2. Okay, V1 into T2 by 2. That is my this distance. Okay, from here to here the distance will be V1 into T2 by 2. From here to here the distance will be V2 into T2 by 2. Okay, so plus V2 into T2 by 2. What I am doing, why I am doing this? Because I want to put T2 here. This is what I want. So from this equation, I'll put T2 here. This is a Erudo question, okay? Good question it is. So from here, by 2 part is getting cancelled, and I can say T2 comes out to be D divided by V1 plus V2. Now you can put that D divided by V1 plus V2 here. So it will become D by, here D by 2 V naught plus T2 is D divided by V1 plus V2. Here my D is getting cancelled, and then the answer will become like 2 V naught into V1 plus V2 divided by V1 plus V2 plus 2 V naught. Okay, getting it or not? Confused? These type of questions are asked in mains. Average velocity questions, average speed questions, half of the time, half of the distance. It's this one question is combination of the two, half of the distance first, then half of the time again. Now let us do this question. This is a value putting question, guys. As shown in the figure, a particle is moving with a constant speed. How much is the speed? Pi meter per second. Consider motion from A to B. Okay, from A to B the particle is coming like this. The magnitude of average velocity is, what is average velocity? Displacement divided by the time interval. That's all. What the particle is coming from here to here. How much will be the displacement? This distance. How much it will take time? You can find. Okay, so give it an attempt. Okay, so try this again. Try this from your side. Give it a try. Let us see how many of you are able to get the question, get the answer correctly. Arun and Padmesh are saying explain once more. Okay, we'll do after this question. I'll come back to that same Erudo question after this. So first do this question. Oh, you got answer also. So how much is my displacement in this particular case? That is this distance. Okay. So how much is this length? You can make a perpendicular here. Huh? This was 120. How much is this? 30. Okay. How much is this? 30. So this is 30. This is also 30. What is this distance? R, because that is equal to the radius. How much will be this then? That will be R cos of 30. This is R cos of 30. Isn't it? How much is this then? That is also R cos 30. R cos of 30. So how much is this total distance then? 2R cos of 30. Okay. So my total displacement is 2R cos of 30 divided by the time it takes t. Now what is the time? What is the time the particle will take to come from here to here? It is moving with a constant speed, that is v. How much is this distance then? A radius into theta, that is an arc now. How much is the length of an arc? R theta. R theta. This distance is R theta. R into what is the theta? 2 pi by 3. So I got that distance. Then how much time it will take? Distance divided by speed. What is the speed? It is pi, but let me put v, then I'll put v as pi. Okay, then put v as pi. So 2 pi r by 3, v is my pi, this is getting cancelled, 2r by 3. Okay, got the time as 2r by 3, put it here. Okay, so 2r cos of 30 divided by 2r divided by 3. Clear? Clear? Then cancel, cancel, and this will become 3 root 3 by 2. Unit will be meter per second. Yeah, so it comes out to be 1.5 root 3 meter per second. Clear, guys? I hope you got it. Previous question I am coming back again because some students are asking, can you repeat it again? Before that, I did these two easy things. Many of you are telling, sir, they are easy. And then you got confused with the third one. Okay. If I divide, let us take a particle is going from here to here. Okay. Half of the distance with speed v1, half of the distance with speed v2. What is average speed? That we need to find here. Okay. In that case, you got it. Total distance divided by time, and then I put it. I got this to v1, v2 divided by v1 plus v2. Next, here half of the time with v1, half of the time with v2, and then when I put it, it came out to be v1 plus v2 by 2. You got it. Now this Erdo question is a combination of the two. First half of the distance with speed v2, v0, next half of the distance is divided into two parts. First half of the time with v1, next half of the time with v2. Now you have to find the average speed. Okay, so when you have to do this, average speed is equal to total distance d divided by total time it takes. I am taking from here to here, it takes time t0, from here to here it takes time t2. So t0 plus t2. Clear? Okay, d divided, what is t0? From here to here, what is the distance? D by 2. What is the speed? v0. What will be time? What will be the time? Distance divided by speed. Isn't it? So I got my this time, distance d by 2 divided by v0. So t0 I got, t0 I put it. Next is I need to find t2. Okay, t2 is the time it takes from here to here, total time. Huh? How much is the distance it is covering? Half of the rest, half of the distance, that is d by 2. Okay, so d by 2 will be this distance plus this distance. What is this distance? It is moving with velocity v1 for half of the time. So v1 into t2 by 2, v1 into t2 by 2 plus v2 into t2 by 2, v2 into t2 by 2. That becomes my d by 2. From there I got my t2. Put that t2 here. Solve, you will get. Okay. Oh, hello, hello. You are from Arjuna JEE. Welcome here. v0 is the velocity. Okay, v0 is given in the question. You see, this is v0 here. The velocity for the first half. t0 I took as the time it takes for covering the first half. Will you be coming back? No, actually, that is the management decision. Okay, so I'll not be coming back. So I hope you got it. Oh, you are from Ellen. Welcome, Yuvraj. So we did this question. You got it. Now let us talk about average acceleration. We discussed about average velocity. Now let us talk about average acceleration. What is average acceleration? So average acceleration is equal to the change in velocity divided by the time interval. Okay, change in velocity divided by the time interval. Like average velocity was change in position divided by time interval. So average acceleration is change in velocity divided by time interval. So I'll say I'll write this change in velocity as the final velocity minus the initial velocity divided by the time interval, which is t2 minus t1. This is my average acceleration. Everyone is talking in live chat that you will be returning in next week. No, who told? No, no. So that was the management decision that time I took. I told you people, like they decided. Okay, so I had to move from there. I'll not be returning next week. Now rate of change of what you are talking about, that is the instantaneous acceleration, that is not average acceleration, Yuvraj. The rate of change, when we talk for a interval, then we talk of average. When we talk a particular instant, then we take instantaneous. Okay, for now we are talking about average things. Okay, in an interval, it's not, yeah. So that will be the instantaneous acceleration that you are talking about. Okay, now let us try this. A particle is moving with velocity 10 meter per second towards east. Okay, how the particle is moving? East direction is towards the right. Okay, towards east. So it is moving like this with velocity 10 meter per second. This is my initial velocity v1. Okay. After 10 seconds, its velocity changes to 10 meter per second towards north. So this is my final velocity v2. Okay, this is also 10 meter per second and it is towards north. The average acceleration is. Now here you have to write properly. Okay, just don't say sir 10 minus 10 or like that. Oh, it will be mistake. If I ask you what is v1, v1 you will say that is your 10 I cap. Towards right we are taking x-axis na I cap. So you will say 10 I cap. What is v2? If I ask you v2, you will say sir 10 j cap. It is towards the y-axis. So v1 v2 like this we wrote. And then if I ask you what is v1 minus v2, like the change in velocity v2 minus v1, v2 minus v1 divided by the time interval. This is how we write na. What is v2 minus v1 divided by time interval? Now if you have to do this, you can do from vectors also. Okay, this was my v1, this was my v2. So v2 minus v1 will be in this direction, opposite. This is my minus v1. 10 meter per second, 10 meter per second, 10 meter per second. Resultant of the two will come like this. How much will be the magnitude of that? 10 root 2. Vector resultant. I hope you are clear with the vector concept, otherwise you will be confused in this. Or you have to do like this. Okay, or you have to do like this. If you want to do like this, you can do like this. It is your final, that is 10 j cap minus the initial, that is 10 I cap, divided by the time. How much is the time? Time is what is the time? 10 seconds. So it is j cap minus I cap. What is the magnitude of j cap minus I cap? Root 2. So the magnitude is root 2. Here also, if you find the magnitude of this v2 minus v1, that comes out to be 10 root 2. Divide that with the time, it will come out to be root 2. What is the direction? Direction is this. J cap minus I cap. That direction is this actually. What is that direction? What is that? East. west, north. So I'll say northwest. Yes, route to northwest. Okay, that direction is like this. This direction is northwest. Towards the right, we take as east. Towards the left, west. Upward, north. Downward, south. So my direction is coming somewhat like this. So I call this direction as northwest. Clear, guys? Now we are coming to the instantaneous thing. When we say average velocity, we say that is change in velocity divided by the change in position divided by time interval. But when we talk about the instantaneous velocity, when we say instantaneous velocity, instantaneous velocity means at a particular instant. Let us take, if I say what is the velocity at t is equals to 5 seconds, that is the instantaneous velocity. What is the velocity at t is equals to 2 seconds, that is the instantaneous velocity. If I say what is the velocity between t is equals to 2 to t is equals to 5 seconds, that is an average velocity. I am giving you an interval, that is an average velocity. If I am giving you one particular instant, that is the instantaneous velocity. So that difference you have to understand, otherwise you will get confused. Okay, so what was my average, by the way? Average velocity was change in position divided by the time interval, like this. Instantaneous will be when this time interval will become very, very small, means at a particular instant. Then we say instantaneous velocity is my rate of change of position. That will become delta r by delta t. Okay, this is my delta r by delta t. Okay, when this delta will become very small, we will use d. Delta will become very small, we will use d. Then we will write that as dr by dt. That will become my differentiation. Okay, so instantaneous velocity is rate of change of position. So rate of change of position, or we write this as dr by dt. dr by dt, rate of change of position, rate of change of r with respect to time, or rate of change of position with respect to time. If your motion is 1D, you will use just x in place of r. For 1D, velocity is dx by dt. For 2D or 3D, the velocity is my dr by dt. R you can write as xi cap, yj cap plus zk cap. So it will become dx by dt I cap, dy by dt j cap, dz by dt k cap, like that. In 1D only x coordinate is just dx by dt. For 2D, 3D, your y coordinate is also there, z coordinate is also there. You have to write for the 3. Okay, you have to write for all the 3. Clear? Good. Instantaneous speed. What is instantaneous speed? If I say you what is the speed at t is equals to 3? Just the magnitude of velocity. So instantaneous speed is the magnitude of instantaneous velocity. It is the magnitude of instantaneous velocity. So just find the magnitude of instantaneous velocity, that will be your instantaneous speed. Questions now. The distance traveled by an object in time t is given like this. The instantaneous speed is, you need just the magnitude. Okay, it is given as a function of time. You can differentiate that. Okay, rate of change of the distance is s. Okay, so you just do ds by dt. Okay, d by dt of 2.5 into t square. 2.5 is a constant, take that out. 2.5 into t square differentiation will be 2t, that will become 5t. So this is my speed, 5t. I need at t is equals to 5 seconds, so put t is equals to 5. Okay, at t is equals to 5, put t as 5, it will become 25 meter per second. Fourth option, easy, huh? Yes, you got it. Next question. The velocity of particle is given like this. The position at x is equals to 0, t is equals to 0, then the displacement after t is equals to 1 second is. Here velocity is given and we have to find the position, we have to find the displacement. Invert thing we have to do here. I'll talk about this question. I think let us do this question first and then we will come to this question after this. Okay. First, let us do this question. Here my position is changing, position is changing like this. I have to tell the magnitude and direction of velocity. So position is this. How to find the velocity? Differentiate that, rate of change of position. Okay, so when I write v, that will be my rate of change of position, isn't it? So t by dt of 2t square j cap plus 5k cap. You have to differentiate this. Now for j cap, when I differentiate it, 2 is constant, t square differentiation is 2t j cap. For k cap, if I write 5 is a constant, differentiation of constant is 0, 0 k cap. It is coming like this. So what it is now, 4t j cap. This is my velocity as a function of time. I need the velocity at t is equals to 1. Put t is equals to 1, you will get velocity as 4 and that comes out to be along y-axis. So 4 meter per second in y-axis. Yes. Now let us go back to the previous question. Here velocity is given. Here I need to find displacement. Okay. So how to do? Particle is moving along x-axis, by the way. So I know velocity is equal to dx by dt. If I take dt on the other side, it will become like this. If I integrate it, time goes from t1 to t2. My x goes from x1 to x2. So it will become x2 minus x1. This is equals to integration of v dt from t1 to t2. What is this? This is change in the position. This is my displacement, delta x. So you just have to integrate it. You have to integrate it to find the displacement. So put it now. What is v? V is equals to v naught plus gt plus ft square. V naught plus gt plus ft square dt. Okay, the time goes from t is equals to 0. Okay, time goes from t is equals to 0 to t is equals to 1. So t is equals to 0 to t is equals to 1. Upper limit, lower limit. Lower limit is 0, upper limit is 1. Now integrate and put the limits. Okay, v naught integration, it will become v naught into t plus g. G is constant, take that out. T integration t square by 2. So g t square by 2 plus f t square integration is t cube by 3. Limit from 0 to 1. So first put t is equals to 1 minus, then put t is equals to 0. Okay, so it will become v naught plus g by 2 plus f by 3. V naught plus g by 2 plus f by 3. Yeah, very good. Option 2. You got it. Okay. Okay, now let us talk about instantaneous acceleration. Average acceleration was change in velocity divided by time interval. So instantaneous acceleration will be a rate of change of velocity. Yeah, it is a rate of change of velocity. Rate of change of velocity. Okay, so when I write acceleration, that I'll write as dv by dt. Okay, if let us take your particle is only moving along 1d, so you will have velocity only along x-axis, you will just write it as dv by dt. But if it is moving in 2d 3d, you are having velocity along x-axis, along y-axis, along z-axis. So you will put your v as vx I cap, vy j cap, vz k cap. So d by dt of v will be your vx I cap, vy j cap, vz k cap, and then you can individually differentiate them. dvx by dt I cap, dvy by dt j cap, dvz by dt k cap. This is your ax. Acceleration along x-axis, ay. Acceleration along y-axis, az. Acceleration along z-axis. Okay, separately. So I can say here my total acceleration is ax I cap, ay j cap, az k cap, like that. Okay, you can write that also. So my total acceleration A is ax I cap, ay j cap, az k cap. For 1D, we are just having acceleration along x-axis, 1D motion. Okay, now let us solve this question together. Let us read it first. A particle is moving in a straight line. The variation of position x as a function of time is given like this. The velocity of the particle when acceleration becomes 0. So this is my position, how it is varying with time. Okay, so I need velocity when acceleration becomes 0. Okay, so first of all, let us find velocity. What is velocity? Velocity is dx by dt. Okay, put x here. What is my x? X is t cube minus 6t square plus 20t plus 15. This is my x. Okay, differentiate that. T cube differentiation is 3t square minus, it will become 6 into 2t, so 12t. Then 20t differentiation is 20, 15 differentiation is 0. This is my velocity. So my velocity is varying with the time like this. I need velocity, but I don't know at what time it is asked. I need velocity when acceleration becomes 0. Okay, let us find acceleration and put that equal to 0. From there I will get time. Yeah. So let us find acceleration. Acceleration is dv by dt. Put that here. d by dt of, what is v? v is 3t square minus 12t plus 20. This is my v. Okay, differentiate that. It will become 60 minus 12. Velocity when acceleration becomes 0. Okay, put acceleration as 0. From here I got time as 2 seconds. So now I need velocity at 2 seconds. Put t is equal to 2 in this. Okay, so velocity at t is equal to 2 will become, put t is equal to 2 there. So 3 into 2 square minus 12 into 2 plus 20. This is how we write that. So what it will become? 3 into 2 square is 12 minus 12 into 2, okay, plus 20. This comes out to be 8. Okay, so the answer comes out to be 8 meter per second. Clear? Next question. This is also a question of Irido. So let us first read it out and then you guys will try, and if you will not be able to do, I will help you. A point traverses half a circle of radius 160 meter during time interval 10 seconds. So it takes 10 seconds to cover half the circle. Calculate the following quantities arranged over time. So you can take your particle is moving in a circle. Particle is moving in a circle from here to here. Let us take the particle is going like this. How much time it took for the particle to go from here to here? 10 seconds. That is given. It takes 10 seconds. Okay. Find the mean velocity. Mean velocity means average velocity. First find the average velocity, displacement divided by time. Then magnitude of mean velocity. Okay. The magnitude of the mean velocity vector. Then modulus of the mean velocity of the total acceleration if the point moved with this point we will have to cover later, we cannot cover this Now, so we will just solve the two parts. Okay, we'll just solve the two parts because that will be covered in the circular motion. So mean velocity. What is average velocity? Sorry, here actually, yeah, one thing here. One thing here that is being, you can say instead of mean velocity, that is being asked is average speed. Okay, yeah. So in first part we need to find the average speed, and in the second part we have to find the modulus of a mean velocity vector. Modulus of the mean velocity vector means you find the average velocity and then tell the magnitude of average velocity. Okay, so what it is? Magnitude of average velocity. That we have to do. So first of all, average speed. Average speed will be how much distance it covered? Pi r. Okay, the distance is covered is pi r. The time it takes, let us take t, pi r by t. Then you put the values. Average velocity will be the displacement from here to here, 2r. The time t, 2r by t. Then put the values, you will get it. Okay, clear. Next, this is a question that we have to solve here. A particle starts moving rectilinearly at t is equal to 0 such that its velocity v changes with time according to the equation t square minus t. This is the equation of velocity. Velocity is in meter per second. The time interval for which the particle retards. Okay guys, particle retards. Particle retards means the particle slows down. When the particle will slow down? When velocity and acceleration, they are in opposite direction. Particle will slow down when velocity and acceleration are in opposite direction. Opposite direction. Direction means here positive, negative. If one is positive, other should be negative. If one is negative, other is positive. Okay. So here, if rectilinearly means, yeah. So rectilinear coordinate system, we call this our x-axis, y-axis. Okay. These are rectilinear coordinate system, perpendicular axis like that. Okay. In this particular case, you can say your particle is only moving in along one direction only. So these x-axis, y-axis, z-axis, these set of coordinates, we call them as the rectilinear system. Okay. So if velocity is positive, acceleration should be negative, or I should write acceleration is negative. Okay. If velocity is negative, acceleration is positive. This should happen. If any of the two is happening, we will say it is a retardation. So then what you need to do? So what you need to do, velocity is this t square minus t, acceleration will be, you can differentiate it. Okay. So velocity is my t square minus t. My acceleration will be differentiation of this 2t minus 1. Now you see from this now you see from these two equations where the acceleration is positive, where the acceleration is negative. Similarly, where the velocity is positive, where the velocity is negative. And then you have to check in which time interval they are having opposite sign. We did this exercise in our class. Okay. So here I am leaving this exercise for you people as a homework. So you have to see where the acceleration is positive, where it is negative, see where the velocity is negative, where it is positive, and then you see in which time interval they are having opposite sign. That you have to do from your side now. Now let us talk about uniform motion. Uniform motion means the particle is moving with constant velocity. Uniform motion means the particle is moving with constant velocity, not speed. I'm saying constant velocity. Both magnitude and the you can say direction should be same. Like if a particle is moving with constant, let us take speed in a circular motion, then we cannot say it is in uniform motion. No, that is not a uniform motion. Uniform motion means the particle should move with a constant velocity. It should move in a straight line with constant speed. Then we will say the motion is uniform motion. Next is uniformly accelerated motion. Uniformly accelerated motion when the acceleration is constant. Acceleration is constant. Let us take acceleration due to gravity. That is always in the downward direction. A particle goes like this, comes back. This is a uniformly accelerated motion. Okay, when the acceleration is constant. Whenever acceleration is constant, we can use these three formulas of uniformly accelerated motion. You all know v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2s. We did derivation for them also in the class. From the differential equation you can derive, like v is equals to velocity is equals to dx by dt. Okay, my acceleration is equals to dv by dt. From those equations you can derive these three. V is equals to v dv by dx from there. These are the three standard equations for uniformly accelerated motion, and all of you have solved questions in 9th class, in 11th class also you might have done that. Using these three equations, we can derive this fourth one also, and we can derive that the displacement is equals to v plus u by 2 into t. That also we can derive. So here now you can say these are 5 equations. Don't remember all the 5, just remember the first 3. Okay. Now let me explain what is this fourth one. SNth. SNth means the distance or the displacement in the nth second. Okay, let us take, if I say the displacement in the third second will be from t is equals to 2 to t is equals to 3. First second is from t is equals to 0 to t is equals to 1. Second is from t is equals to 1 to t is equals to 2. Third, t is equals to 2 to t is equals to 3. So nth will be t is equals to n minus 1 to t is equals to n. In that interval, how much distance it will cover or how much displacement it will cover, that is s nth. How to find that? You can find that like here my s nth is s n total in n minus in n minus 1. The distance, the total displacement in n seconds minus the displacement in n minus 1. I will get the displacement in that interval which we are calling as snth. Okay, now you put it here. Sn, displacement in nth till nth second. So s is equal to ut plus half at square. So we'll write as un minus un plus half into half a into t square n square. This is Sn minus Sn minus 1. So that will become u into t is my n minus 1 plus half a into n minus 1 square, like that. Now you subtract the two and you will get this. So you just have to remember the first 3 and then the fourth one and the fifth one you can derive also from your side. Okay, clear? Let us do this question. A bullet is fired in a fixed target, loses 1/3 of its velocity after traveling 4 centimeter. It penetrates further this distance before coming to rest. Okay. So a bullet is going like this. Initially some velocity v, okay, loses 1/3 of its velocity. If the displacement here is 4 centimeter, the velocity here will be loses 1/3. It means 2v by 3. Then 2v/3. Okay, so now next it penetrates further this much distance before coming to rest. Okay, now how much distance? Let us take some distance, you may take that as x. After further traveling x, it comes to rest. It comes to rest. Now you have to find how much your x will be. What you have to consider, acceleration is uniform in this case. So write the equations, try to solve this. Okay, write the equations, try to solve it. Give it a try. Just try it. Right? Write the equations just. Which equation you have to write, you think? Okay, three equations you are having. From three equations, which equation you have to write? Think. Initial velocity, you know. Final velocity, you know the distance or the displacement. Here, initial velocity, you know. Initial, you know. Final, you know. You have to find the distance. Here. Huh? Which equation? V square minus u square is equal to 2as. V square minus u square is equals to 2as. Final velocity 2v/3 minus initial velocity square is equals to 2 into acceleration, I don't know, into the displacement is 4 centimeter. This is the first case. Second, final is 0. So final square minus initial 2v/3 initial square is equal to 2a into the displacement. Let us take this as x centimeter. So x centimeter, divide the 2. Divide these two equations, a will get cancelled. 2 also will get cancelled here. This v is also getting cancelled. Then it will become 4/9 minus 1 divided by minus 4/9 minus 4/9, and that will come out to be 4/x. Okay, then 9 you can write 9 here. It will become minus 5 divided by minus 4. Okay, so it will just become 5/4. 5/4, it is 4/x. So x comes out to be 16/5. X comes out to be 16/5 centimeter. I took this as x centimeter, so 16/5 centimeter. I have to convert it into meters. So 16/5 into 10 to the power minus 2 meters. Multiply and divide with 10. Okay, multiply and divide with the 10. 5 into 2, it is 32 into 10 to the power minus 3 meters. So this d comes out to be 32. Clear? Getting it? Okay. Next question. A car is moving with velocity 150 km per hour, and after applying the brake, it will move 27 meter before it stops. Okay, so here you can say this car was here. It was moving with some velocity v, which is 150 km per hour. Okay, now brakes are applied. It takes it 27 meter to come to rest. If the same car is moving with velocity 1/3 of the reported speed, it will stop after how much time? Here the speed is v/3 and it stops somewhat here. What will be this distance we need to find? Acceleration is same in both the cases. Acceleration is same. Okay. Lecture duration, it's still 9 p.m. Okay. Acceleration is same in both the cases. So, which formula we should use? I think the same formula, v square minus u square is equal to 2s. In this particular case, what is final velocity? 0. Initial velocity is v is equal to 2a. What is the displacement? 27. Equation is okay? Yes. Second case, final velocity 0 because it stops, minus initial velocity 1/3 of that v by 3 is equals to 2a into how much is the displacement? How much is the displacement? I don't know. That is what we have to find. Okay, let us take that as x. Divide these two equations. V square getting cancelled, 2a getting cancelled, and from here I got x as 3 meters. X comes out to be 3 meters. Clear? Good. Another question, let us read it. A person standing near the edge of the top of a building throws two balls A and B. This is a question from H.C. Verma. A is thrown vertically upward, B is thrown vertically downward with the same speed. The ball A hits the ground with speed V and B, VB. We have to find the relation between VA and VB. I think this is just a common sense question that you all can just see and do. Here we are throwing this with velocity V like this. It went, came back, this velocity is VA. The next case is you are throwing down. You are throwing down from here. You are throwing down like this with same velocity, V, same velocity V in both the cases. It is reaching the ground here with velocity VB. The question is, what is the correct relation? VA is greater than VB, VA less than, or both are equal? You tell which relation is correct. Think about it. Think about it. This height is same for both the cases. Both the velocities will be equal. Both the final velocities will be equal. How the final velocities will be equal? You can write the equation v square minus u square is equal to 2s. Final velocity square is equal to initial velocity square, whether it is positive or negative. V square is V square. Okay, downward acceleration is same in both the cases. Final velocities will be equal. VA will be equal to VB. Displacement is same. Acceleration is same in both the cases. A car, next question, accelerate from rest at constant rate 2 meter per second for some time, then it retards at a constant rate 4 meter per second square and comes to rest. If it remains in the motion for 3 seconds, then the maximum speed attained by the car will be. How the motion is? Let us take the car is going from here to here. Okay. So initially the car accelerates with constant acceleration 2 meter per second square. Okay, so let us take from here to here. It starts from rest. Here the velocity was 0. Here acceleration is 2 meter per second square in this region. Then for some time, then it remains in motion, then it retards at a constant rate of 4 meter per second square. Okay, after this it is retarding. After this it is retarding. Retarding means acceleration negative, and then finally comes to rest. Finally comes to rest. This is how it is happening. Okay, if the time of the motion is 3 seconds, okay, means from here to here it takes 3 seconds. from here to here. Then the maximum speed attained by the car. Where the car will attain the maximum speed? It will attain at this point. Acceleration was positive till here. Now, after that acceleration is negative, velocity is decreasing. So, this is my maximum velocity here. I need to find this maximum velocity. Okay. So, initially you can take from here to here, the time it takes is t1. From here to here, the time it takes t2, and I can say t1 plus t2 is equal to 3. Okay. Then I can say that. Okay, then let us use this relation to find t. V is equal to u plus at. I am using v is equal to u plus at, u plus a into t. For the first interval, what is final velocity? V max. So V max is equals to, what was the initial? Initial 0. What is acceleration? Acceleration is 2. What is the time? Time is t1. Okay, I got my t1 as V max by 2. Okay, then in the next interval from here to here, again I am using the same formula, V is equals to u plus at from here to here. What is the final velocity? 0. What is the initial velocity? V max. What is the acceleration? Minus 4. What is the time? T2. So I got my T2 as V max by 4. T1 plus T2 is equal to 3. Put it, V max by 2 plus V max by 4 is equals to 3. From here we have to find V max. Okay, so I will say 3 by 4 V max is 3. V max comes out to be 4. Clear? Next question, guys. This is a next question on uniformly accelerated motion only, and I think you can do all these questions, or should I do this? Let us see how much time is there with us. Okay, so many questions I brought on uniformly accelerated motion. Let me do this question and the next question, and then few questions I'll leave for you people to solve. Okay, as a part of homework, then you can take this PDF, okay, the notes, and then you can solve from your side. Let us do this question. A bus starts from rest, moving with acceleration 2 meter per second square. Okay, so a bus is there. It starts from rest. Initial velocity is 0. It is having acceleration 2 meter per second square. Okay. A cyclist 96 meter behind the bus starts simultaneously towards the bus. Okay, so here is a cyclist and it is 96 meter behind the bus. It starts simultaneously means at the same instant with velocity 20 meter per second. 20 meter per second, which is constant. After what time will he be able to overtake the bus? So let us take at after some time t. After some time t, this picture was at t is equal to 0. Okay, this picture is at t is equal to 0. After some time t, the bus, okay, the bus you can say came here. Okay, the bus came here and the cyclist overtook the bus at this instant, means the cyclist also came here at the some particular time t, like this. So how much distance bus traveled? This is my displacement of the bus. How much is the displacement of the cyclist? This is the displacement of the cyclist. So I will say that the displacement of the cyclist is equal to the displacement of the bus plus 96 meter. I will say this is the relation. Now you just put the values. What will be the displacement of the cyclist? It is moving with 20 meter per second. So 20t is equal to, what is the displacement of the bus? S is equal to ut plus half at square you can use. What is u? U is 0. It will be just half at square. So half acceleration is 2 into t square, half a t square plus 96. So this is a quadratic equation now, and we can solve this quadratic equation and we will get the solution of this quadratic equation where the cyclist will overtake. We will have two solutions. First time the cyclist will overtake the bus. Next time, now speed of the bus is increasing, bus will overtake the cyclist. So two solutions will come here. So we have to write the first time, okay? First time when cyclist will overtake the bus. Let us see this question also. A body starts from rest, is moving under a constant acceleration up to 20 seconds. Okay, if it moves s1 distance in first 10 seconds, s2 distance in next 10 seconds, what will be s2 in terms of s1? Okay, so s1 distance in first 10 seconds. So s1 will be s is equal to ut plus half at square. U is 0 because it is starting from rest. So I'll just say half a into t square. In next 10 seconds, the distance traveled is s2. So my s1 plus s2 will be the distance traveled in 20 seconds. First 10 s1, next 10 s2. So in first 20 seconds, it will be s1 plus s2. Huh? Okay. Now just divide these two and you will be able to get what is your s2. So s2 will come out to be 3s1. Divide this, a will get cancelled, half a, this and this will get cancelled, and you will get s1 divided by s1 plus s2. That will come out to be 1 by 4. And then you can just solve it quickly. Easy. Okay. Clear? I hope you are getting these things. Now we are having some questions. I'm leaving for you people this question, this question, this question, this question and this question. We did so many questions on uniformly accelerated motion. The rest of these questions you can solve from your side. Now we are moving to the next part of this topic, that is motion under gravity. Let us take a break. It's 7:22. I'm taking a 10-minute break and we'll get back at 7:32. Okay. So we are back, guys. Motion under gravity is uniformly accelerated motion. So we have to use the same three equations considering the acceleration to be g. That's all. But yes, we have to be careful with the sign convention here in this case. Okay. Like the same three equations, s is equals to ut plus half at square, v is equals to u plus at v square minus u square is equals to 2s. We'll be using same three equations, and the acceleration is g, that is in the downward direction. Okay. So let us take, you can take like first simple thing. Let us derive. You are throwing a ball vertically upward, it goes like this, comes back. Let us find the maximum height it will achieve. Let us find when it will reach at the maximum height. Let us find the time of the flight. Let us find these fundamental things first. Okay. Now, when it will reach the maximum height, we know the velocity there will be 0. Which equation to use to find the time? V is equals to u plus at. Where is the acceleration? Acceleration is in the downward direction. How much is the acceleration? That is equal to g. Okay. I am student from Arjuna JEE English 2027. Okay, Hari. Now here we will use the equation V is equals to u plus at. We'll use this equation, simple. Okay, what is the final velocity there? 0. What is u? Is in the upward direction. I'm taking upward as positive. Upward direction positive, downward direction negative. U is plus u. Acceleration is in the downward, minus g. Here I'm taking the time to be time of maximum height, th. From here, you got your time of maximum height as u by g. Okay, so I am saying that you have to use the same three equations, nothing new, but only thing is you have to be a bit careful with the sign convention. If I take this as plus g, the time will come negative. You have to be careful with the sign convention. Now, this is the time it takes to reach the maximum height, same time it will take to come back, twice of that. Time of flight will be twice of that. Okay. How to find how much height it will achieve, the maximum height? You can use, the final velocity, the initial velocity, the acceleration. You can use v square minus u square is equals to 2s. Okay, so let us use v square minus u square is equals to 2s. Final velocity is 0, initial velocity is plus u, acceleration is minus g, the displacement here is plus h because it is in the upward direction, plus h. From here, I got my maximum height as u square by 2g. Okay, sign convention is very, very important here. Yes, Hari, my father is all right now. He's recovering. Everything is good now. Okay, now let us take a particle is dropped from certain height. You are dropping a particle from here. Initial velocity is 0. It come like this. What you have to find? How much time it takes to come down? How much will be the velocity, the final velocity here we need to find. How much is this? Let us do this. The acceleration is in the downward direction. First of all, let us find the time it takes to come down. I know the displacement, I know the initial velocity, I know the acceleration, I have to find time. Which formula? S is equals to ut plus half at square. What is the displacement? Minus h. Okay. What is the initial velocity? 0. Okay. What is the acceleration? Minus g. Time I have to find. This is my equation. From here I got my time under root of 2h by g. So the time it will take for a particle to fall h height is root of 2h by g. Okay. And then what else? Let us find the final velocity also. V square minus u square we will use. So v square minus u square is equals to 2a into s. Okay. What is the final velocity? I have to find. What is the initial velocity? 0. what is the acceleration? Minus g, minus g. Okay. What is the displacement? Minus h. My final velocity will be root of 2gh. If it falls a height h, the final velocity will be root of 2gh. Okay. I remember you, Hari. I think you are the same Hari. Your name is Hari only, na? In batch also. So I remember you. I hope everything is fine. So now can I take Lakshya batch? What I have to do after buying? Like after buying, you have to study there. I'm not clear. Like what you want to ask? I'm not clear with that. Sorry to say. Like if you are purchasing a batch, you have to study there. Like means what? Yes, you can take Lakshya batch. Lakshya batch is there. I'm not in Lakshya JEE, by the way. Sir, how are you? I am from Arjuna JEE in English batch, the crazy gamer. Oh, what is your name? Like I know you people, but you have to mention your name, na. Otherwise, how will I know who is this crazy gamer? Please mention your name. It's late. Yes, it's late. Yes, it's late. You will get recordings of those classes. Okay. Then you will have to cover the backlogs from there. You have to cover them. Then only you will understand the things further. Yes, you can purchase. There is no issue in taking the batch. Certainly, you can take the batch at any time. You can take the batch, but you will have to cover the things till now. Okay, whatever is covered in the class. I am Ijwa. Okay, okay, Ijwa. Got it. Got it, Ijwa. How are you, Ijwa? Ijwa is there. Hari is there. So many people are there. Huh? Gagan. Hmm. Gagan, I don't remember you from the batch. I think you are not there in the batch. It's already late now, sir. I have to listen past classes. Yes, you will have to listen the past classes. Yes, you have to listen if you are taking that. Hmm. Oh, you are in Arjuna NEET. Okay, I took some classes in Arjuna NEET. Where is class notes, sir? These class and the last class notes, I'll ask them to upload in the description also in our WhatsApp channel. Let us see. I'll ask them. I think they forgot. I mentioned to them, but I'll again ask them to upload them on the WhatsApp channel and in the description also. Okay, they'll give the link of the WhatsApp channel. Now, let us solve this question. A ball is thrown vertically upward with velocity 19.6 meter per second from top of a tower. Okay. This is the tower. From here, you are throwing the ball vertically with 19.6 meter per second. The ball strikes the ground after 6 seconds. Okay, the ball goes like this, strikes the ground, and in this whole interval, it takes time 6 seconds. Means if I take here, the time is 0, here the time is 6 seconds. Okay. Then the height from the ground up to which the ball can rise will be k by 5, the value of k is. So this height I have to find basically. How much will be the height the ball can rise from the ground? Okay, okay. Ball is thrown at from this at t is equals to 0 when it will reach the maximum height, by the way. U by G, 19.6 by 9.8. 2 seconds. In 2 seconds, it will reach the maximum height. In 4 seconds, it is falling. Here t is equals to 2, here it is equals to 6. So the time it takes from here to reach the ground is 4 seconds. Means it is taking 4 seconds to fall. How much is this height? It is falling in 4 seconds. You can use the formula S is equals to ut plus half a t square from here to here. How much is the displacement? I have to find. Okay, let us take this height as h. So my displacement will be minus h. Why minus? I am taking downward as negative. Here my velocity is 0. Okay, 0 plus half. What is acceleration? Minus g into the time from here to here is 4 seconds. So into 4 square. you have to put G as 9.8, okay, G as 9.8, and then you will get what is the value of H from there. So you will get from here H comes out to be half into G into 4 square is 16, and this is given as K by 5. So put this as K by 5. Put G as 9.8 and then find the value of K. Sir, I am Suchika from Arjuna JEE English. Hello Suchika, how are you? Okay. Next question. Let us do this question. A body projected vertically upward with certain speed from the top of a tower reaches the ground in time t1. Okay, means you are throwing a ball like this, it will go up, come back, and it takes time t1. Then if it is projected vertically downward with the same speed, it reaches in time t2. Okay, so if we are projecting it like this, it will go in time t2. Okay, with the same speed. Let us take this speed is u here, this speed is u in the downward direction. Then the time required to reach the ground if it is dropped from the top of the tower. Dropped from the top of the tower means if you drop the ball from here, means at rest, v is equals to 0. Then how much time it takes? Then how much time it will take? Okay. Kuldeep. Oh, Kuldeep is also from Arjuna JEE in English. All my students are here, huh? So we have done these questions in the batch. It's a backlog class. If you have done these questions in the batch, then it's not for you. Otherwise, you can revise here with me. Okay. So here I have to relate T1, T2 and T. So how to relate? Let us write one by one equations. Initial velocity I know, final velocity I know. Let us take this height as h. Then I can use S is equals to ut plus half at square. Okay, this formula. What is the displacement? From here to here, downward, na, minus h. So minus h, this is displacement, is equals to u. U is upward, so plus u. ut1 plus half. Acceleration is minus g in the downward, na, minus g into t1 square. So S is equals to ut plus half at square. Then for this, u is in the downward direction. Displacement is same, minus h is equals to u is in the downward, so minus u t2 plus half minus g into t2 square. Got this second equation? Now for this, initial velocity is 0. Okay, acceleration is in the downward direction, displacement is minus h. So what is that? Minus h is equals to u is 0, so it is just half minus g into t square. Three equations, three variables. Which are the three variables? H is variable, U is variable, and my T is variable. Three equations, three variables, and if you solve these three equations, you will get your time T as root of T1, T2. I'm leaving that exercise of solving the equation for you people. Okay, you can do that as a homework. We did that exercise in our batch. Okay, now you can do this from your side. Can you can you explain how many problems each chapter, sir? Okay, so you are asking, so how many problems to do in each chapter? Like, it's individual, it's up to you. If you are confident by doing 200 questions, okay, move ahead. If you are saying, sir, I did but I'm not confident, do 500. Okay, you'll say, no sir, I just need some more exercise after, then do 1000. It's up to you. Okay, but the thing is, in each and every concept, after solving the questions, you should get that confidence that any question from this particular topic I will be able to solve. Let us take, you did 100 questions in motion under gravity, and after doing those 100 questions, you got that any question from motion under gravity I can solve, and you tested yourself, you took some 10 questions or 5 questions from any of the book and you are able to solve. Okay, then you got the motion under gravity, move to the next topic, like that. Okay guys, next question. A stone is dropped from a bridge at a height 180 meter over a river. After 3 seconds, a ball is thrown straight downward. Okay, what should be the initial velocity of ball so that the both hit the water simultaneously? Let us take height of the bridge as somewhat like this. This height is 180 meters. Stone is dropped. Stone is dropped means left at rest, 0. The stone will go like this, strike the ground. This is at t is equals to 0. This is at t is equals to 0. Let us take it reaches the ground here at some time t. After 3 seconds, at t is equals to 3 seconds, I am throwing another ball vertically downward. Vertically downward. With what velocity? I don't know. Let us take with velocity v. Okay, and it reaches the ground. They both reach the ground simultaneously. They both reach the ground simultaneously. If for this it's take time t to reach, for this it will take time t minus 3 to reach. Isn't it? Nah? I am dropping it, I am throwing it actually 3 seconds after. So how much time it should take for it? T minus 3 to reach. Displacement is same. Now write the equation. Which equation I should use? V square minus u square is equals to 2s. No, I don't know the final velocity. S is equals to ut plus half at square. Yes, I can use that. Okay, let us write it for this particular case. S, displacement minus 180 is equals to u is 0, t plus half at. Okay, so plus half. A, what is acceleration? Minus g, that is in the downward direction, minus g into the time it takes t square. Okay, clear. Now for this write the equation. What is the displacement? Minus 180 is equals to u. What is u? U is minus v, that is in the downward direction, minus v into the time t minus 3 plus half minus g into t minus 3 square. What we have to solve? You have to solve for v from here. You can get time from here. Put the time in this equation. You can get what is the value of v. Okay, two equations, simple. It's a quadratic equation. Okay, you can put g as 10. G as 10. This is getting cancelled. Minus sign is getting cancelled. 18 into 2 is 36. You got t as root 36, means 6 seconds. Then put t is equals to 6 seconds in this equation. Can you get v from there? Yes, easy. Easy. So just solve the equations then. Okay guys, next question on motion under gravity. A ball is dropped from a balloon going up at 7 meter per second. If the balloon was at 60 meter height from time of dropping the ball, how long will the ball take in reaching the ground? Okay, the balloon was at 60 meter height, means this height 60 meter. You dropped something from the balloon. What will be the velocity of that? You will say, sir, dropped, we are dropping from rest. No, not dropping from rest. The balloon is moving with some velocity. The velocity of that dropped will also be the same. Everything inside the balloon, okay, with the balloon will have the same speed. So it will be going up with 7 meter per second. So when you leave it, it will go like this and then come back. How long it will take to reach the ground? You can find the time. How to find the time? Displacement you know, velocity you know, initial acceleration you can you know. Okay, then write the equation s is equals to ut plus half at square. Let us write that here. So s is equals to ut plus half at square. What is the displacement? Going up, coming back. Displacement is in the downward direction. Minus 60 is equals to, what is u? Plus 7. Time t I have to find, plus half. Acceleration minus 10. Okay, minus g. So minus 10 into the t square. This is a quadratic equation you can solve and find the value of time. Easy. Just you have to write the equations and solve them. Okay, so let us further solve some questions on this. What is the time, by the way? It is almost 8. A person standing on the top of 25 meter high building throws a ball vertically up at speed 20 meter per second. Find time the ball will take to come down. Means this height is 25 meter. You are throwing this with 20 meter per second. You have to find the time it takes to come down. Similar to what we did in the last question. Okay, so write the equation S is equal to ut plus half at square and solve for time there. Huh? S is equal to ut plus half a t square. What is the displacement? Minus g, sorry, minus h, okay, minus 25. So minus 25 us plus 20 time we have to find acceleration minus g t square. This is a quadratic equation you can solve and get the value of time. Easy. Okay, next question. Similar type of question, exactly similar type of question. Okay, so but just you have to find the relation here. So write the equations and you try it from your side. I'm leaving this as a part of homework. This is a good question. A body is thrown vertically upward. Which of the following graph represent the velocity versus time? This is a graph question. We have to cover graph first. Huh? We have to cover graph first to discuss this. But let us. I think you know basic fundamentals of the graph. Then we can do this. We know acceleration is equals to slope of the velocity time curve. Acceleration is constant, by the way, when the ball is coming down. Motion and gravity, acceleration is constant. If acceleration is constant, the slope has to be constant. Slope is not constant. Slope is not constant. Slope is not constant. Slope is constant. This is correct. Okay, acceleration is constant. Acceleration is slope of velocity time curve. Therefore, the slope has to be constant. Here, only this is having constant slope. Same straight line means constant slope, same slope throughout. Next question. Okay, this is also another question. You can do this from your side as part of your homework. A ball is thrown upward with velocity this, it will reach ground after, what is this? This simple question. You can do this also as your homework. A stone is thrown upward and rises to height 200 meter. The relative velocity of stone with respect to earth will be maximum at. That also you can do. A balloon starts rising from the ground with a constant acceleration. This rises 8 meter. Right after 8 seconds of rise, the stone is released from the balloon. Anyways, I'm leaving these all question for you people. You have to just write the equations and solve them. You can do these questions after the class. Okay. After the class, you do all these questions. Now the next part, next topic is air resistance. Let us take, when I'm saying the ball is going up, the ball is coming down, we are taking the acceleration to be constant, okay, g, and we are not considering any of the forces, like, you know, ball is going up, ball is coming down, air is also there. Will there be any drag due to air? Yes, there will be drag due to air. Okay, so some resistive force will be there. So let us consider that resistance. Let us consider that resistance. When, okay, I'm talking about first the upward motion. Okay, so you are throwing the ball like this, the ball is going upward. When the ball is going upward, the air will apply resistance in which direction? Opposite, na? Opposite to velocity. So my acceleration due to that resistance will come in the downward direction. This is due to air resistance. Acceleration due to air resistance. And yes, acceleration due to gravity is in the downward direction. So in this motion, total acceleration is in the downward direction, g plus a. Okay, so sorry. So in this, when the ball is going like this vertically up, my total effective acceleration became g plus a in the downward direction. G plus a in the downward direction. Then you have to just use the equations, okay, taking acceleration to be g plus a in the downward direction. You can write the equations and you can solve. For the upward motion, okay, for the upward motion, sorry, for the downward motion now. For the downward motion means the ball is coming down from the means it it goes first upward and then comes down. Now it is coming down. While coming down, where the air drag will be opposite to the velocity, na, so air drag will be like this. Okay, this is due to air resistance, due to air resistance. Okay, and acceleration due to gravity, that is always downward. Acceleration due to gravity is always downward. So in this particular case, the effective acceleration in the downward direction will be g minus a. While going up, the acceleration in the downward was g plus a. While coming down, the acceleration in the downward is g minus a. Acceleration is different while going up and while coming down. Therefore, the time it takes to reach the maximum height and the time it takes to come back from the maximum height will be different because the acceleration is different. That is the difference here. Okay, and we are having this question on this difference. Let us read this question. An object of mass 5 kg is thrown vertically upward from the ground. The air resistance produces a constant retarding force of 10 Newton. 10 Newton force, mass is 5, means the acceleration will be force by mass 10 by 5, 2. So acceleration due to air resistance is 2 meter per second square. A. The ratio of time of ascent to time of descent. Time of ascent, going to the maximum height, okay, then coming back from the maximum height like this. While when it is going to the maximum height, you can write half a. When it is going up, the acceleration is g plus a in the downward. While it is coming down, the acceleration is g minus a in the downward. The height is the same. So while going up, you can write h is equals to half g plus a into t ascent square. While coming down, h is equals to half g minus a into t descent square. And then you can take the ratio of the two. You need the ratio of the two, na? Just take the ratio of the two. So you'll get t ascent divided by t descent will be equal to g minus a, okay, divided by g plus a root of that. What is a? A is 2. So it will be root of 10 minus 2 divided by 10 plus 2. Root of 2 is to 3. What is it? Is time of ascent to time of descent. Yes, root of 2 is to 3. That is the second option. Clear? Easy? Good. Now let us discuss about graphs. So first of all, we are talking about position time graph. Okay, let us draw some position time graph. So I'm talking about 1D here. So I'm taking my position as x, time as t. If I ask you, the position time graph is like this, what is the velocity? What you will say? You will say that the position is not changing with time. If the position is not changing with time, the particle is at rest. Yes, the particle is at rest. Then if I ask you the position time graph is, let us take like this, then in this case what will be the velocity? Whether it will be positive or whether it will be negative or whether it will be constant or like that, what it will be? Okay, so I know velocity is equals to rate of change of position. What is this? This is slope of dx by dt is slope of xt curve. So I can say velocity is the slope of position time curve. Position time curve. Slope of the position time curve. Okay. If the straight line is like this, what is the slope? You will say, so slope will be tan of this theta. Is that positive or negative? Positive, because the angle is in the first quadrant. So you will say here your velocity is positive and it is constant, because a straight line have a constant slope. Has a constant slope. This is a straight line. Its slope is constant, so velocity is constant. Okay. Okay. Let us take the velocity time curve is somewhat like this then. Slope is constant, velocity is constant, but the slope is negative. So here I will say velocity is negative and constant. Okay, negative and constant. Getting it? Okay. Let us talk about when the velocity is not constant. This we got velocity is constant for these cases. Let us talk about the case when the velocity is not constant. Velocity is not constant, acute angle yield positive. Yeah, acute angle yield positive slope. Here it is obtuse, so here it is the negative slope. Very good. Now, let us talk about the cases when the velocity is not constant, when the velocity is increasing or the velocity is decreasing. Position time xt. Let us take some curve like this. If I ask you, tell me whether here the velocity is increasing with time or decreasing, can you tell me? Okay, you can try, because we know velocity is slope of the acceleration time curve. Here the slope is negative, here the slope is 0, here the slope is positive, velocity is negative, then 0, then positive. It means velocity is increasing, isn't it? Negative, 0, positive. Velocity is increasing. If velocity is increasing, acceleration is positive. Acceleration is positive. Okay, let us take the other curve when the acceleration will become negative. xt. If I take this curve to be like this, here what is happening? Here you will say at this point the slope is positive, at this time the slope is 0, here it is negative. So the slope was positive, 0, then negative. Slope is decreasing. Decreasing means velocity is decreasing. It means acceleration is less than 0. Velocity is decreasing, acceleration is less than 0 in this case. Okay. पीडब्ल्यू में क्यों नहीं पढ़ा रहे हो? आई थिंक मैं पीडब्ल्यू में ही पढ़ा रहा हूँ राइट नाउ. ओके, आई एम ऑन द पीडब्ल्यू प्लेटफॉर्म. Now, let us solve this question. Match the column question, it is here. What we have to match? xt curve is given and we have to match for the vt curve. Okay, in column 1 we are having x2, in column 2 vt curve. First of all, let us do the simplest one. Xt curve is a straight line, slope is positive, so velocity is constant and positive. That is the first one. Velocity is constant and positive. So I am getting first for D. So for D I am getting the first one. Now here velocity is constant positive, then constant negative. Which option? Here. This option is matching. Okay, which one is this? This is third actually. This is third and this is fourth. So I am getting third for C. Now let us talk about the rest too. Okay, A, upward parabola. Upward parabola means acceleration, like if upward parabola is there, acceleration is positive, that is there, but acceleration is also constant. For parabola, acceleration is constant. So acceleration is positive constant. Velocity time curve will be having positive slope, then only the acceleration is positive constant. So I am getting second for the A. Remaining will be for B. What is that? The fourth one. Okay, that's all. Now let us talk about the velocity time curve. Velocity time curve. English for backlogs. Thank you. Yeah, welcome. Velocity time curve. Okay, let us take a velocity time curve. First, this is velocity, this is time. Okay, first of all, let us see the mathematical relation. I know that acceleration is equals to dv by dt. I know this. Yes, I know. From this equation, I can say acceleration is slope of velocity time curve. Yes, I can say. Okay, so I can say acceleration is slope of velocity time curve. I got it. Find the slope of velocity time curve, that is my acceleration. Okay, then is there any other relation with the velocity? I know v is equals to dx by dt, isn't it? Yes. So from here I can say my dx is equals to v dt. When you will integrate it time t1 to t2 from x1 to x2, you will get here delta x, which is x2 minus x1. And here it is integration of v dt from t1 to t2. What is this? This is my displacement. This is my displacement. What is this integration? This is area under vt curve. Area under vt curve. So my displacement is equal to area under velocity time curve. Okay, area under velocity time. So you find the area under velocity time curve, that will be your displacement. Okay, so simple thing first. If the velocity is like this, velocity is not changing with time constant, acceleration is 0. If the velocity time curve is like this, acceleration is positive and constant. Acceleration is positive, constant. If the velocity time curve is like this, acceleration is negative because slope is negative. So negative and constant. Acceleration is negative and constant. Okay, and also if you have to find the displacement, then find the area. We will have some questions on that, don't worry. Let us solve the question, you will get an idea what I am talking about. From the VT curve shown, the ratio of distance to displacement in 25 seconds of the motion is ratio of distance to displacement. So when you find distance and displacement, what will be the difference? Here the velocity is negative. The particle is moving in the opposite direction. For displacement, you have to take this area as negative because the velocity is negative. For distance, we will take this also as positive. That's all. That is the only difference. Okay. Now, let me find the area of each of this section one by one. So I can find this area of this triangle. This triangle I can find this how? 1 by 2 into base 5 into the height, which is 10. So this is 25. Okay. Then let us find this area. How much is this? 5 into 10. This is 50. Okay. Then let us find the area of this trapezium. 1 by 2 into the sum of parallel sides, 10 plus 20, that is my 30. Okay, 10 plus 20 is 30 into the separation between them is 5. This comes out to be 75. Then let us find this area. How much is that? 1 by 2 into the base 5 into the height, which is 20. This comes out to be 50. Then let us find the area of this. How much the area will be? 1 by 2 base 5 into the height, which is 20. This is also 50. Now the thing is, when I will say my displacement, area under the curve, this area plus this area plus this minus, why? Velocity is negative, displacement is negative there. Displacement is a vector quantity. You have to check the sign also. So this will be 25 plus 50 plus 75 plus 50 minus 50. Okay, and when we talk about distance, negative side, even if the particle is moving, add that, we are finding total path length. So it will become 25 plus 50 plus 75 plus 50 plus 50. That's all. Now you do the calculations. Yes, you got it perfectly. And then you can do. So this comes out to be our 5 by 3. Now let us talk about the acceleration time curve. Okay, how we relate acceleration? By the way, I know acceleration is equals to dv by dt, isn't it? So my dv is equals to a dt. Okay, integrate it. Velocity goes from initial velocity v1 to final velocity v2, v1 to v2. Okay, time goes from time t1 to t2, like this. What it will become? v2 minus v1 is equals to integration of a dt t1 to t2. What is this change in velocity? What is this area under the curve? So here we got that change area under the acceleration time curve is equals to change in velocity. Okay, this is how we say. We took a break. We already took a break. We took a break for 10 minutes. So now we are winding up the session. Okay, so I'm not planning any break now. We'll cover for half an hour. Okay, and then we will end this session. So I can say that area under the acceleration time curve is equals to change in velocity. Okay, so area under acceleration time curve is equal to change in velocity. That's all. Change in velocity. Let us do this question. What it is? This is a VT curve and we have to draw AT curve. Okay, it's a simple one. VT curve. Negative slope, acceleration is negative, then positive slope, acceleration is positive, constant. So negative slope, negative, then positive slope, positive. So first negative constant, then positive constant. First negative constant, then positive constant. Easy. A particle starts from rest. Its acceleration time curve is given, which varies with time as shown. The maximum speed of the particle will be. Where the maximum speed will be? Maximum speed will be here. Why? Acceleration is positive till here, na? Acceleration is positive till here. So I need to find the velocity here. Here we are having maximum velocity. What is, how the velocity is related with acceleration time curve? Find area, that is equal to change in velocity. Find this area. How much? 1 by 2 into the base 6 into the height 5. So 15 meter per second. This is my change in the velocity. Okay, at t is equals to 0, it starts from rest. Okay, it starts from rest. Initial velocity was 0. So when I will say my change in velocity is equal to the area under, area is 15. Final velocity v max. Initial velocity 0 because it starts from rest. So it comes out to be 15 meter per second. Clear? Okay. Clear? I hope you got it. Next question. This is a good question, by the way. Let us try to do this. This is a very good question. A ball is dropped vertically upward, ball is thrown vertically upward with velocity 20 meter per second. Equation of motion, okay, using equation of motion, make these graphs: VT graph, AT graph, displacement time, speed time, and distance time, all these. So let us go one by one. So first of all, VT curve. Let us do VT, huh? Or which one? Yeah, let us do VT curve first. How the velocity is changing? Acceleration is constant, VT graph will be a straight line. Yes. The ball is thrown like this with 20 meter per second. It comes back with 20 meter per second. At maximum height, the velocity will be 0. Initially positive, then negative velocity. Okay, okay. Then what is the, by the way, like what is the relation between velocity and time? Linear relation. You can use equation V is equal to U plus AT. It's a straight line relation. Okay. So this is my velocity. This is my time. Initial velocity is plus 20. Okay. Plus 20. Final velocity is minus 20. And the relation is straight line. In between, the velocity reaches 0. So the graph will go somewhat like this. Plus 20, then 0, then minus 20. Okay, this is how the graph will be. Now, next time, okay, let's talk about AT graph. AT graph. How to draw the AT graph? Acceleration is constant only in the downward direction. So acceleration is negative only. Huh? Acceleration is negative only. So if I draw the AT graph here, this is my acceleration, this is my time, acceleration is constant, negative, minus g, that's all. This is my AT graph. Huh? Okay, this is my AT graph. Then next, which one to do? Speed time. Let us do the speed time. You got the velocity time curve. Can you draw the speed time curve? Easy. Why? Speed is just the magnitude, okay. So when speed can never be negative, speed is just the magnitude, can never be negative. When it is negative, make it positive. Okay, so if I draw the speed time curve here, the speed time curve will go like this. It will go like this, like this. This is my speed time curve. Then okay, then which curve to do? Let us do displacement time graph now. This is a good one, by the way. Okay, let us talk about displacement. Displacement time. So this is my ST curve. The ball was going like this and then coming back. Okay, then it is coming back. While going up, what is happening? The velocity, the acceleration is downward only. Okay, the acceleration is downward only. The velocity is in the upward direction and it is slowing down. If I have to write the equation, which equation I'll write? V square minus U square is equal to 2s. No, S is equal to UT plus half AT square, that I will write. Okay, that will be a quadratic equation, means a parabolic relation will come. How it will go? If a parabolic relation will be there, initial displacement is 0 till it reaches maximum height. It goes like this. Okay, somewhat like this. Here it reaches the maximum height. After reaching the maximum height, it will be coming down, certainly. Okay, displacement is decreasing, it will be going like this. It's a downward parabola. Acceleration is negative, therefore downward parabola. Acceleration is constant and negative, therefore downward parabola. Okay, okay. If this is the displacement time curve, what will be the distance time curve? Distance can never decrease. When it is decreasing, Just keep on adding. So the distance time curve will go first like this, then like this. So this is my distance time curve. I think we did all of them. Yeah, very good. Let us move ahead. So these are the curves. You can have a look. Okay, this is the Erudo question. And here what we have to find? We have to draw, let us read it first. A point traverses along x-axis with a velocity whose projection Vx is represented as a function of time in the plot. Assume the coordinate of the point x is equals to 0 at t is equals to 0. Draw approximate time dependence plot for acceleration and the x coordinate. First of all, let us draw the acceleration. Acceleration drawing is very simple. Here acceleration is positive constant, then acceleration is 0, then acceleration is negative constant, then acceleration positive constant, then acceleration is 0. Means just the slope I am seeing. I am just seeing the slope. Okay. So first I am drawing the AT. Okay, see carefully, see carefully. From here to here, what is the slope? 1 by 1. So acceleration is plus 1, plus 1. From here to here, what is the slope? 0, because this is horizontal. What is the acceleration? 0, 0. Acceleration 0. From here to here, acceleration is negative. How much? Minus 1. Okay, minus 1. From here to here, the acceleration is like this. Then here it is plus 2. Here the slope is twice, 2 by 1, okay, it is plus 2. Then acceleration is plus 2 from here to here. Then acceleration 0, okay, after that is 0. So this is how the graph goes. Positive, 0, negative constant, positive, then 0. Okay. And then we have to draw the x coordinate, and the x coordinate and the distance covered s. Okay. So x coordinate and the distance, you can both, first x coordinate means the displacement time curve, that is same as the x coordinate curve here. So displacement will be area. Okay, and if you see it is positive constant, here it will be an upward parabola kind of graph. Then it will be a straight line because the velocity is constant. Then it will be a downward parabola. Then it will be a upward parabola. Then it will be a straight line. This is how the xt curve will go. This is how the xt curve will go. So here my x is 0. Okay, from x is equals to 0, from t is equals to 0 to 1. Okay, 0 to 1, my graph, xt graph, how I should draw xt. So initially it will be an upward parabola like this, because the acceleration is constant, positive. Then it's a straight line, velocity is constant, it will be a straight line. So upward parabola, then a straight line. Okay, then a downward parabola. Okay, then a downward parabola. Whether the displacement will become 0 or not, then you can check with the area of the graph. Okay, but I'm just giving a rough understanding from here. Okay, then it will be a downward parabola. Then again a upward parabola here. Okay, then again upward parabola, and then a straight line, because that is again a, so not it is 0, then it is 0, then it will come out to be rest like this. So it's a rough idea. Exactly what you have to see, where it will whether it will cross the x-axis or not, then you have to calculate that. Okay, so first upward parabola, then a straight line, then a downward parabola, it crosses the x-axis. How you will get the, I didn't showed here whether it will cross the x-axis or not, because I have to calculate whether it will cross the x-axis or not. How to calculate that? You find the displacement where it is getting 0. If it is getting 0 at a particular instant, there it will cross the x-axis. So it is crossing the x-axis. It is crossing the x-axis means it will come somewhat like this. Okay, like this, and then a upward parabola is there. Okay, then a upward parabola is there for the next, and then it is constant. Why constant? Because then the velocity is 0. Okay, so some part for upward parabola then you can show, and then a constant velocity, sorry, constant position, because the velocity is 0 there. So this is how the xt curve is coming. Now if you ask, sir, can you draw the distance time also here? Distance can never decrease, distance will always increase. Till this point the displacement was increasing. After this, the displacement is decreasing. Now you have to add that. How much it is decreasing, that you have to add that. So it will just become the mirror image of this. So the distance time curve will go like this beyond this. Till here, distance and displacement were same. After this point, this curve is just the mirror image of that, as we discussed previously. Confusing? Repeat once again, sir. Okay, okay. Now xt curve is a confusing because that is area. Okay, here acceleration is positive, constant. Upward parabola it will be, see this region, it is clearly drawn here, upward parabola till here. Okay, till this you can say it is upward parabola. After this it is a straight line. Why straight line? Velocity is constant. If velocity is constant, xt curve will be a straight line. After that it is straight line, straight line. Okay, after that the velocity is decreasing, acceleration is negative, downward parabola. Okay, downward parabola, it will go like this, it cross the x-axis. After that acceleration is again positive, means some part again upward parabola. Okay, again it is an upward parabola. After that velocity is 0. Okay, velocity is 0, x will become constant, like this. Okay, so this way you have to think. Now displacement you got, how to draw the distance time curve. So till displacement is increasing, distance is equals to displacement for 1D motion. Okay, so till here both the curves are same. After this displacement is decreasing, can distance decrease? No, distance will keep on increasing. Mirror image of this. That's all. Okay, now velocity displacement graph, which we call as Vx curve. Okay, I know acceleration is equals to dv by dt. If I multiply and divide with dx and take this dx on the left, it will become like this. This dx by dt I can say again it is my velocity, so it is v dv by dx. So my acceleration comes out to be v dv by dx. Okay, and now if velocity displacement graph is given, you can write the equation, you can use this mathematical relation, and then you can solve for whatever is asked there. This is an example for that. Let us do this and then you will understand it. Here we are having a Vx curve. Vx curve, what generally whenever they will give, that will be a straight line. So very easy to write the equation of a straight line. Y is equals to mx plus c. That way we write the equation of a straight line. Okay, y is equal to mx plus c. What is my y? Y is my v, velocity along y axis. What is the slope? Minus v naught by x naught, minus v naught by x naught into x, plus the intercept is plus v naught. So this is my velocity and displacement equation. Okay, if this is v, I need ax graph. Can I find acceleration? Yes, v dv by dx. Acceleration is equals to v dv by dx. Put the v, get the a. Okay, a is equals to v. V is minus v naught by x naught into x plus v naught. Okay, then d by dx of this whole minus v naught by x naught into x plus v naught. If you differentiate it, what will it will be? Just the slope minus v naught by x naught. Okay, so it will become v naught by x naught whole square into x minus v naught square by x naught. This is what I'm getting for acceleration. Now this is also a straight line relation. A y is equals to m x plus c, but here slope is positive, intercept is negative. Slope is positive, intercept is negative. First option is matching. It's a English channel, so no Hindi on this channel. Okay, so no Hindi here, only pure English. So here find acceleration at s is equals to 0. S is equals to 0 is here, isn't it? This is s is equals, no, this is s is equals to 50, sorry. S is equals to 0 is here. This is my s is equals to 0. I need what there? I need acceleration. How to find acceleration? v dv by ds. Okay, what is dv by ds? Slope of vs curve. This is a vs curve. What is the slope? Here my slope is equals to 20 divided by 50. This is a negative slope, so slope is minus 2 by 5. Okay, dv by ds is minus 2 by 5. What is v here? 20. So 20 into minus 2 by 5. That's all. I got the acceleration. Clear? Okay, this is another question you can try from your side. I'm writing this as a homework for you people. Then v square s graph. Okay, now if the standard graphs are there, you can understand the standard graph. Xt curve is there, Vt curve is there, At curve is there. These are our standard graphs and we remember them. Okay, like the slope of that, area of that, slope of other, area of other, we understand. Okay, what is the slope, what is the area for a standard curve. If the curve is not standard, then what to do? Then you have to apply mathematical equations like the way we did for Vx graph. I wrote the equation first and then we did. There you, I don't encourage you to remember, otherwise how much you can remember? There is a limit, isn't it? So don't remember, understand it, try to write the equations and try to solve those equations there. So here let us take V square S graph is there. So if you take the slope, that will be dv square by ds, it is coming out to be like this. So here I am getting v dv by ds comes out to be half of slope. What is v dv by ds? That is my acceleration. So if v square s graph is there, half of that will be, half of the slope will be my acceleration. But I don't remember this. I will understand that I can write this from here. Write that from here. So that you have to do. Okay, so these substandard graph you can just write, here you have to just apply that thing. Okay, take half of the slope, that will be your acceleration. Here you have to find acceleration, take half of the slope, that's all. V square s. Just a second, previous question which I did, this was just vs. Yeah, I was thinking like that was v square s. The data is same, by the way. Okay guys, this is our as curve. Here you can write your a as v dv by ds, and from here you can see the area of under the curve comes out to be like this. But again I am saying, don't remember anything, just understand that if as curve is given, then use the as relation. A is equals to v dv by ds. If you integrate it, it comes out to be like this. Don't remember it, that's all. Okay, we are having some questions here, and these questions will be for your practice, okay, after the class. So we have done the question of the graph, so this question is also your homework. The next question here, this is also your homework. Okay, these are simple questions. This is VT curve. Huh? You can solve all these questions. This is also VT curve. You can find what is asked here. The distance traveled. Distance means just add all the area. That's all. Okay, just add all the area. Here what we need, the acceleration and retardation, that is the slope. Okay, so just you have to do that way. So this is also your homework. Then this is also your homework. Then this is also your homework, and this is, and the next one this. So all these graph questions I am leaving for you people as part of your homework. Now the last thing, let us talk about the relative motion. Relative motion means you are observing, relative motion means you are observing the motion of other with respect to something. Like if I am sitting on the ground and then I observe a bike moving, okay, or if I am sitting in a train, then I observe the bike moving, the two observations will be different completely, isn't it? Like let us take, if the bike is moving with the same speed, I am sitting in the train, I'll say the bike is at rest. Okay, so the velocity of the bike relative to train is 0 in that case, isn't it? If I am sitting in the train, the bike is moving in the opposite direction, I will say the bike is moving with very high speed. Okay, so that is the relative velocity of the bike with respect to train is very high. Okay, on the ground I am seeing the velocity of the bike with respect to ground. Okay, so relative motion means changing the frame of reference. You are observing the motion of one particle with respect to other particle. You just sit on the other particle and then see how the first particle is moving now. That is the thing. Okay, so when I say, let us take particle A is there, it is having some velocity VA. Particle B is there, it is having some velocity VB. Okay, so when I say velocity of A with respect to B, velocity of A with respect to B, okay, that will call as velocity of A relative to B, same thing. Okay, velocity of A relative to B, that we write as velocity of A relative to B, that is my velocity of A minus velocity of B. Here you are sitting on B and then you are observing A. That is the thing. If I say velocity of B with respect to A, that will be velocity of B minus velocity of A. It is just the opposite. It is minus of velocity of A with respect to B. Okay, so my frame of reference is changing here. This is for velocity. You can write for acceleration also. If I say acceleration of A with respect to B, that will be acceleration of A minus acceleration of B. If I say acceleration of B with respect to A, that will be acceleration of B minus acceleration of A, which is just the opposite of acceleration of A with respect to B. So, and also I can find the relative position also. I can say like my position of A with respect to B will be position of A minus position of B. And then I just use all the equations. Let us take, if relative acceleration is constant, then I can use the uniformly accelerated formulas, but everything, all the values which I'll put there will I'll use as a relative. For velocity I'll use the relative velocity, acceleration I'll use the relative acceleration, displacement I'll use the relative displacement. That way, use the same equations, you will get. Okay, so this is how the relative things work. I will give you some example. Relative motion under gravity. Okay, before that, let us understand some basics also. Let us take, this is my car A. It is moving in this direction with 20 meter per second. This is car B. Okay. It is moving in this direction with 10 meter per second. Okay. Now, if you ask B, the driver which is sitting in B, he will observe A is coming with a greater speed, isn't it? He will feel A is coming with a greater speed. Actually, he will see that A is coming with 30 meter per second. Its velocity is also adding there. How? If you say velocity of A with respect to B, that will be velocity of A minus velocity of B. What is velocity of A? Plus 20, because it is in the positive x-axis, plus 20, or you can say 20 I cap. What is velocity of B? Minus 10. So minus 10, 30 meter per second. So actually, if you ask the B person, how high you feel this, how is the velocity of A, the car A which is coming from the front, he will say car A is coming with 30 meter per second, isn't it? We feel now like we are driving something, somebody is coming from the front, okay, towards us, we will feel that velocity to be very high because it is coming towards us. My velocity and his velocity, they are adding up actually in magnitude. This is coming like this, 30 meter per second. Okay. And if you find the opposite, it will come out to be minus 30 meter per second. If they are moving in the same direction, 20 meter per second, 20 meter per second, let us take 10 meter per second. Now, if you ask what is velocity of A with respect to B, here I will say velocity of A which is 20 minus velocity of B which is 10. This is only 10. This is only 10. That is the difference. In the class, we did so many questions on relative velocity. Okay, so if you have to like need some more questions for these relative velocity, okay, so that is there in the detail. So you can watch the lecture in Arjuna JEE batch on relative velocity. So relative motion under gravity now. Okay, so two balls are under gravity, means they are under free fall. Okay, so when the balls are under gravity, what is the acceleration of the two? Each is having g. This ball is also having acceleration g in the downward direction. It is also having acceleration g in the downward direction. What is the relative acceleration in this case? Relative acceleration is 0. Relative acceleration is 0. Okay, so relative acceleration, okay, for motion under gravity is 0. If relative velocity is 0, it means relative velocity, if relative acceleration is 0, it means relative velocity will be constant. Yeah. Relative velocity is constant. That is not changing. Let us solve this question. A ball A placed at top of 180 meter tower, ball B, ball A is placed at top of 180 meter tower. So let us draw first. So here ball A, okay. Ball A is released from tower at t is equals to 0. Okay, it is released now with velocity 0. Ball B is thrown vertically up from the bottom with an initial velocity u. Okay, it is thrown up with initial velocity u. At the same time, after a certain time, both will meet 100 meter above the ground. Okay, so they are coming like this. Let us take they collided here. This is A, this is B. This is at time t. Find the value of u if this collision happens 100 meter above the ground. This is 100 meter. So what is the value of u? I can do this question without relative velocity also, but I want to do with relative velocity here. So if I ask you what is the relative acceleration? 0. A relative is equals to 0. V relative is equals to constant. What is that? That is equals to u only. It is thrown with u. The magnitude is u only. That's all. Okay. How much was the total height? This total was 180 meter. Yeah, 180 meter. How much time it will take with respect to B? Okay, I'm observing with respect to A. Okay, with respect to A, how much time B will take to hit A? It is traveling how much distance? 180. What is the speed? U. The time it will take to strike will be 180 divided by U. Okay, 180 divided by U. So this is the time it will take them to strike each other. Okay, now what I need, by the way, I need the value of U. I can relate, if I can find a T, I can get the value of U. That way also I can do. Or here, it is taking time T to drop till this, and in the same time it is traveling this. So I can say how much is the distance it dropped? It dropped a distance of 80 meter, isn't it? 180. So in dropping 80 meter, how much time it will take? Root of 2h by g. So root of 2 into 80 divided by g, this will be my time. That comes out to be root of 16, which is 4. Put t as 4. That will give you the value of u. Simple. Okay. So yeah, this is another question for you people. As part, no, this is a simple question actually, not a relative velocity question. Anyway, you can do this as homework. This is a simple question for you. Okay guys, so here we are ending this discussion. This is 8:49 and we have touched actually all the topics. We certainly we did need the derivations and all on many of the things which we have covered in the class. And yes, if you need details of these, sir, lot of questions you gave as a homework. Yes, I had to give them as a homework. Okay, in 3 hours, we cannot cover everything. So some questions for you to practice, some questions I did in the class. Now, if you need details, let us take for relative velocity or any of the concept, you can go and watch the detailed video on our Arjuna JEE English. So there you will get the complete details. So thank you all guys. Bye-bye. We are ending this discussion here.